Okay, so it's a new development. Okay, so again, think of MATLAB like a computer, sort of calculator, and you can define variables like equals 1. And if you notice when I said a equals 1 and a colon, it didn't print anything. But if you say b equals 2 and don't put a semicolon, then it actually prints out. So the way you want to learn about MATLAB is to just interact with it. And if it doesn't like it, it'll complain. So c equals d. She didn't like that command. And the way to really work with programming is a programming language will tell you errors. Look at the errors and debug the errors. That's the way to do it. And I would say it's much simpler than doing mechanical engineering or hardware stuff, because when you get an error, something doesn't work, you don't know, but programming language actually complains and tells you why it's complaining, and so you can fix the error. So there's no D, and that's why it complains. You could do C equals A. So this whole MATLAB is based on, it's called MATLAB is Matrix Laboratory. There is a seat right here. Are you a graduate student?
Yes.
What's the department?
Mechanical.
Mechanical. Okay. When you look at C equals 1 for MATLAB, it is actually a matrix. It treats that as a 1-by-1 matrix. So we just start with matrices. For example, if you want a 2-by-2 matrix, 2, 3, 4, and what does that mean? Well, if you just suppress the semicolon, it actually tells you what A is. A is a 2-by-2 matrix, 1, 3, 2, 4. Okay. Let's refine B as 2, 3. Okay. So this is a 1 row, 2 columns. So 1-by-2 matrix. So the good thing on MATLAB is you can do once you have things in MATLAB, you can just do things like addition, subtraction, and so on. So let me define B, and instead of defining a matrix, there is a library of matrices which can be randomly determined. So I want a 2-by-2 matrix consisting of random numbers. I say rand 2, 2. So rand is a function, and I'll talk about function scripts a little later. So that's B. Okay, so if you have A, which is this, B, which is that, you can do A plus B. If you wanted to print, you suppress the semicolon. So that's A plus B. I've also defined a small b, which is 2, 3. If I do A times B. Okay, so there's an error. It says in a matrix dimensions must agree. So the rule for multiplying a matrix A with B is that the columns of B should equal the number of rows of the second matrix, right? So what's the size? So there's size of A is 2, 2. Size of B, small b, is 1, 2, and we should have the columns of A should be equal to the number of rows of B, right? For multiplication, that doesn't work. However, if we can transpose B, right? Transpose is, if you want to find the transpose of B, all you do is B with an apostrophe. That's 2, 3. Now, if you look at the size of B, that's 2, 1. So they should be compatible. So if you write A times B, the apostrophe, you can multiply them. So you can do A times capital B, which is 2-by-2 times 2-by-2. It's compatible. You could do A minus B, and so on. Okay. If you want to find the transpose of A, again, do the same thing. Transpose. Okay. There's something called a determinant of A, and if you are, what I really like about MATLAB is that it's been somebody really writes good documentation for this software. And so if you want help, let's say that you want to find determinant, okay, which is a very standard thing, and you think that maybe determinant is, maybe there's a command called, a function called determinant. It says undefined function or variable determinant. So you could actually go to, well, best way you could do is to go to Chrome or your browser and search MATLAB determinant. And a lot of programming is actually looking at the web, finding chunks of code and copy pasting it. So don't feel free to do that. That's good practice. You do not have to write code yourself. If somebody has uh, done the job of writing code, just copy it. That's absolutely fine. It's not considered plagiarism in this world. When it comes to writing, yes, if you copy somebody's text verbatim and paste, then yeah, it's considered plagiarism. But for code, no. What happens is when you see somebody's code, they usually put a Creative Commons license which says that if you use this code, cite me. So they just use it to put that particular blurb inside that code, and you should be fine. So do not worry about copying code from the internet. So go to the website. I just put determinant MATLAB, and then it says, well, the command is det and not determinant divided. And then it actually tells you how to use it. D equals det a returns determinant. So let's try that. Equals det a. So it's -2 is the determinant. Now, if you knew that dit is the command for determinant, but you do not know how to use it, and you do not have internet connection, you cannot go to Chrome, then if you actually type help dit, it should actually tell you how to use determinant. Dit x is the determinant of square matrix. And the thing which I really like about MATLAB is that it actually gives you a hint. C cond. So sometimes what is COND? So you say help COND. Okay, COD is called a condition number. Okay, if you don't know about that, don't worry about it. But then it gives you hint. Why don't you look at these things? So there are other functions which MATLAB has given you, which you do not have to write from scratch. So not might be interesting. So let's try help. Okay, there are a bunch of prompts. If I could fill the page. Yeah, so lots of things. So the thing is, if at all you're in doubt, you could write a function which does determinant. MATLAB has done the work for you. Don't write it. Just search for determinant, use it. It also has written so many other functions, so do not try to write your own code unless you have to. Okay. What I do is I try to see if MATLAB has a program or a function which will do the job. If not, then I'll search the web. If I can find it, I'll just plug it in. I will not try to write a single line of code unless I have to. And that's the smart way of doing work. Don't try to reinvent the wheel. Don't try to write your code. Sometimes when people submit code, one of the issues, well, this code, you don't have to worry. It's solid, strong. They have tested it multiple times. There are people in MATLAB who wrote it, but when you pick code from the internet, sometimes they are faulty. So you got to be careful when you use code from sources which, could be somebody who's writing his assignment. There's a bug in the code and it may not work, or it'll give you, it works in some cases, it doesn't work in some other cases. And that will not happen with MATLAB code in general. That is the code which is written by folks in MATLAB. Okay, so what else? Okay, so what I forgot to tell you is that the stuff over here, this is your workspace. These are all the variables which I have defined in the course of writing all these things down. So A is 1. By the way, I should maybe increase the font on this. You can actually fonts. Should have done this in the beginning. 18, okay. Okay, now it's a little better. It's bigger. It doesn't somehow blow that up. So it's much bigger. Yeah. Okay. So, anyways, these are the things which I wrote down. A equals 1. Capital A was my matrix. It actually has everything in the memory, so you could reuse these things. So if you did not want some variable, you could say clear. Let's say I want to clear off A. Okay. Now A actually disappeared from here. So if you try to use A again, it's going to say undefined variable. It says, did you mean capital A? And not so. Okay, so that's about using variables. Now you could do plotting. Okay, you learn about you do this with your calculator, but you could also do it with MATLAB. Let's say we want to plot the sin x function. Okay, so first I need to create points, right? So if I say sine of x, then x, I want x to be from 0 to say 2 pi. So the command which does that for you is linspace, okay, 0. That's actually something which you can do, which is it actually gives you a hint how to use it. This was not done in previous versions of MATLAB. So 2 pi. Okay. What this does is essentially puts dots from 0 to 2 pi. It actually does, by default, it does 100 dots. You could change that to do 1000 if you want. The default is 100. Okay, so it does that. I don't want to print it, but nevertheless it printed it. Y equals sine of x. Okay, I save that in memory, and then I do plot x comma y. Okay, so plot of x comma y didn't show up. Oh, it's because this is open. Let's close this and then rerun it. Okay, you can actually, if you want it, if you want to find coordinates of a specific point, you can actually use the marker and then put the cursor wherever you want to put it. Okay, and then there are a bunch of things. You can increase the thickness of that line. You could change the color from blue to red or whatever. So here's the best way to learn about this is, well, as I said, plot is a function. So you say help plot, and then it tells you a lot of things about the plot function. The good thing is it just, besides just telling you plot is blah 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 blah, it is actually goes ahead and gives you an example. It actually gives an example of how to plot this function, some complicated function. So another way of programming, and this is something which I really like to do, is I want to basically do plot of sine x. I take this code, paste it, I reproduce the results, and then I just take the line which is not of interest to me, this one, right? I replace it with sine of x, and also of course this one, and then I can just use their code and sort of use that template and modify the code to suit my own needs. So anyways, this is the plot function x comma y, and the bunch of instructions. So let's see if we can try to understand all this. So here's another way of learning how to program by not doing much work. Take that. Since I already defined x, already defined y, I can reuse that code. So let's see what. Before that, let me close this. Close all that command actually closes all windows. Okay, I copy pasted that thing from the example. I think it's all ready to go because I've already defined x and y. Let's see what happens. Okay, you got something. Now you can, if you want to explore what's going on, you could actually look at the instructions, what plot does, but you could also, it's actually quite easy to understand. Marker size should be, it's basically the size of the green blobs. Marker face color, G is green. Marker edge color, the edges of the marker is K. K is black. So you can see the blobs are black, have a black background. Line width is 2. That's the line you can't quite see the line there because the markers take the line. And then R I think is red, S is square. And so really there are so many things here, but you don't quite see the. So what I'm going to do is get rid of a few things. And of course, I have to close the window before I do that because it'll, maybe I think it'll work. Let's see. Let's keep the window as it is. I'm going to get rid of everything except this. Let's see. Okay, so that generated that. So x, y, sine you've seen. The dash is the lines, dashed lines. R is red. You see S is the squares. Okay, so if you want to complicate it a little bit more, let me get rid of that. There was a slide error. It actually turned out that there was a comma here, and I should have moved this up. And so instead of trying to write all that down, if you use the up key on your screen, up on the right side, just below the shift, it'll actually tell you all the commands which you have typed. You don't have to retype or retype or copy paste. So let's get that, get rid of that. Okay, there it is. So this is the new one with line width 2. So if you if you remember what was there before I put this command, the line was not so bold. Now it has a line width of 2, which is looks more bold. Let's copy paste. Okay, I'm going to get rid of the marker edge color. Again, same issue, so go back. Okay. There it is. Okay, the edge color shows up as black. So really what I'm trying to show you is that it's not hard. I know mechanical engineers, the major complaint I hear is that program is so hard. And how can I do it? Well, it's really this. It's really, you play with it and you don't treat it like, oh my God, this is so much code, lines of code. It's just what it is. You play with it, you see the results. In fact, I would say it's really easier compared to dealing with hardware stuff, like a car or a car breaks down, you got to fix it. Most likely you don't know what's going on, and then you have to do a bunch of tests to figure out this thing. For programming, it's so easy because it tells you line, we'll see later on, it says line 20, there's a problem. So you just look at line 20, you fix it. It'll tell you line 30, there's a problem, you go and fix it. So it's actually pretty simple to program than it is to fix hardware. And I don't see, and I just see that why, I don't know why people, especially mechanical engineers, complain about programming. This is actually simpler than fixing a car or doing hardware stuff. Okay, there are other functions. For example, if you want to create a bunch of ones, let's create one. So if you want to call that O equals ones. So how do I know about these things? Well, let me do help ones. So it is a bunch of instructions about how to use ones, but then it also tells you look at I and zeros. So what is I? Help I. I is the identity matrix. If you want to create the 2 by 2 identity matrix, I2. That's identity matrix. So you don't have to write that, type it down. You just say I2 and it creates a matrix for you. But the other, so it told you, well, look at all these things. Let's look at, we looked at rand. Rand is just the random numbers, but normally distributed random numbers. Ones, zeros. I don't think we saw zeros. So zeros. So if you do zeros, 2, it will create 2 by 2 zeros. But if you say m comma n, so it will create a m by n matrix. So let's look at the second one. So zeros equals zeros 2 comma 3. So 2 by 3 of zeros. Okay. Why is it useful? You see sometimes you want to initialize the matrix. You don't have to write that down. You just put zeros 2 comma 3 and you get what you want. Okay. So I really encourage you to play with MATLAB. Okay. Do not think of it as hard. There's help all the time. Its help is through just typing help or going online. Okay, so I expect you to know vectors. So I'll start with vectors, and then I'll show you can actually do vector manipulation using MATLAB. And if time permits, we'll go on to the next part. So so again, you don't have to write things down. I'll provide all my notes. So this is a review of vectors. Okay, so scalars have magnitude. A equals 1, B equals 2. Scalars, vectors has magnitude and direction. So Okay, the way you denote vectors is, let's say A is a vector, you denote it with an arrow on top of it that denotes it's a vector. We'll be looking at vectors which are at the most 3 dimensions. Okay, so they would have a x component, a y component, and a z component. Okay, when you talk about simplest example of vector would be if you want to find where let's say this where this paper is on the table, and if you fix a coordinate frame, let's say it originates from the corner of the room, then the center of this paper has a certain x component, which is something you measure in the x axis, y component, z component, and so the way you write a vector is the ax, ay, az denotes the position along the x-axis, the y-axis, and the z-axis. So I, j, k are unit vectors, along axis. You need to know the magnitude, which is the magnitude of the vector is ax square plus ay square plus az square. Now you sum the thing and then you take the square root. Okay, so what it denotes is for the point which is in the midway of the paper, the magnitude denotes the distance of that point from the origin. Okay, which is a distance, it's a scalar. So this is magnitude. Then let's move on to the direction. Okay, the direction is denoted by what is known as a unit vector. So as you can see, I had the I hat, j hat, k hat, similarly I would have a hat, which is a unit vector. And the way you write it down is you take the vector itself, a, and you divide it by the magnitude, so that what happens is eventually it doesn't have its magnitude is 1 because you took itself and you divide it by its magnitude. That's how you denote it, and you can write it as axi plus ayj plus azk divided by what I wrote down for the magnitude. Okay, so once we are ready with vectors, let's talk about manipulation of vectors. So we had multiplication, summation, and so on for matrices. Similarly, you can do addition, subtraction of 2 vectors, but what we're most interested, and this will be something which will come in the course again and again, is the dot product of 2 vectors. So let's define another vector before we do that. Let's call it b. bxi plus byj plus bzk, and the dot product is denoted by a dot b. In order to find the dot product, what you do is you take the x component of a, multiply with the x component of b, so ax times bx. You sum it with the y component of a and b, and az, bz. So you take the components of x, well, the individual components, multiply each of them together, and that's how you get the dot product. Okay, there's something called a cross product. This is a bit more involved, so you need to do this particular manipulation, which I'm going to show you. Ax, ay, az, bx, by, bz. And if you remember how to do that expansion, it's essentially using the determinant formula. So if you've forgotten, well, basically you don't have to know too much about manipulation, really do these calculations, because since all the homeworks and all the finals is going to be offline, it's at home, you can actually use MATLAB to do all this computation. So you don't have to remember. So don't worry if you have forgotten about this. I'll actually show you how to use MATLAB to find that determinant. Anyway, the way you do it is, for those people who are interested, you expand along any row, any column. Most preferred is you expand along the first row, I, and then you take whatever is left after eliminating. So I is belongs to the first row, first column. So you look at what remains when you eliminate the first row, which is this one, the first column. So if you eliminate the first column, first row, you're left with that, and then you find the determinant of that. So that is basically AY times BZ minus AZ times BY. So I'm going to write this quickly. AY BZ minus AZ BY, and then out of space, so I'm going to write minus J. So this is basically the formula for expanding this out. AX times BZ. So I'm doing this with J. So I have this, and this. AX minus times BZ minus AZ times BX, and then plus K X times BY minus AY times BX. Okay, so that's the formula. So thing to note, this is a scalar. There's no IJK, and this thing here is a vector. Okay, a cross product will give a vector, dot product will give a scalar. It's always true. Okay, now I'm going to show you a trick how to do A cross B using matrices. Okay, and this is something which will be used again in the course, become again and again. I'm going to show you how to do A cross B without using this formula. You're going to use a matrix multiplication to do it. So what I claim is another way to do cross product, okay, only with or with matrix multiplication. So here's how you proceed. If you want to find A cross B, you write A in a very special way. Okay, the way it's written down is this way. It's called a skew symmetric matrix. There's zeros on the diagonal, and then minus AX, AY minus AZ. Okay, got to remember that. And then what you do is you reflect the entry and you switch the signs. But when I say reflect the entry, you're going to write AZ. So minus AZ is in row 1, column 2. You're going to write AZ in row 2, column 1, and switch the signs from minus to plus. Same thing for AY, and same thing for AX. Okay, so there's no other way, but you got to remember that. And you get used to it once we see it many times. I'm going to write BX as it is. Okay, so now I have a 3 by 3 matrix times a 3 by 1 matrix. So I can do the matrix multiplication. Okay, so I don't know if some of you might have forgotten how to do that. You essentially you take the first row and multiply it with the column BX, BY, BZ element wise. So that means 0 times. So this is how you do the multiplication. Do 0 times BX, which is 0, minus AZ times BY, and then AY times BZ, plus AY times BZ. So that is a single number, right? If you have values for AX, AY, AZ, that will be a single number. AY times BZ. So this would give you a 3 by 1. So let's proceed same way. AZ times BX, 0 times BY is going to be 0, and then minus AX times BZ is going to be minus AX times BZ, and then AY times BX plus AX times BY, and then 0 times anything is 0. So what you got is A cross B Okay, you got three rows and one column. What that really means is that's the first one is the I component, the second one is the J component, third one is the K component. So let me write it down that way. So minus AZ BY plus AY BZ I plus AZ BX minus AX BZ J plus minus AY BX plus AX BY K. Okay, so that's what I got by doing the matrix method. Let's compare this with what I got earlier and see if they match up. So I'm going to copy paste this thing. Okay, so let's see. AY BZ minus AZ BY. AY BZ minus AZ BY. So the first term matches. The second one is AX. There's a minus sign, so I can put that inside because there's a positive sign here. So minus AZ BX with a positive sign, AZ BX minus AX BZ, same thing. AX BY minus AY BX. So it's same thing. Okay, so this is how you do it with matrices if you are not comfortable using the determinant formula. But this is a trick which we'll be using. This is a trick we'll be using again and again in the course. Okay, questions? Okay, so you do not need to know how to do these multiplications by hand because MATLAB will do it for you. Okay, so I'll show you how to do it in MATLAB. And then we can actually leave early today. I want to do scripts, but I can do it next time. I think there's enough to do. So what I want you to do is go home and try to play with MATLAB a little bit because next time I'm going to do a little bit more complicated stuff, which is using functions and scripts. So let me show you how to do matrix multiplication, cross product and dot product using MATLAB. Okay. Lot of mess here. You want to clear off the mess. Try CLC. It's clear. You don't like this workspace. This is you want to start a new option. You can actually clear this off by saying clear. The clear will work. It's all gone. Okay. Okay. So let's. Okay. Let's define vector. Vector is a special case of a matrix, right? If it always has three, well, in our case, three-dimensional vectors, we have either 3 columns, 3 rows. So let's create something like this. So that's a 1 by 3 matrix, but you can think of that as a vector. B as let's use rand 1, 3. Some random number. Now, if you want to do the cross product, okay, just write cross. So it did the cross product without having to do that complicated calculations. You want to do the dot product, scalar, right? Okay, so remember we did the cross product two ways. We use cross A comma B, which is using the determinant formula. You could also do this using the other formula which I told you about. Let's try to do it that way. So A cross B. This is just a variable I wrote down so that I can compare it later on. So remember I showed you a skew symmetric matrix. It looked like this, 0. Then I need to put negative AZ, the Z component of A. Now A has three parts to it. There's 1 by 3. So what I'm going to do is minus A3. This is the Z component. And then I need to write the X component. So that's my first row of A. Then there is A3, 0, minus A1. And then finally, let's check this. So if I AZ, A3 is 0, minus A1, yeah, and then finally minus A2, A1, and 0. Okay, so I've successfully transcribed what I wrote down for that A matrix. Remember, it was a skew symmetric matrix. Essentially, I've tried to write this down. Okay. So I think that's my left part times. Remember, B is 1 comma 3, so it's like this. I need to make it into a column matrix, so I need to do B transpose. This is what I get for A cross B. If I compare it with cross AB, you can see that the X component is the same, Y component is the same, and Z component is the same. So you could do it using matrix or using cross product. Something which I'll teach you later on is you can actually do symbolic calculations. So these are all numeric, right? If you want to do symbolic, then you need to define symbolic variables AX, AY, sims, AZ. Real, that's saying that by default numbers, variables are defined as complex numbers. You don't want them, so real. It should be sim, AX, AY, AZ, real. Sims is the right command. Sims bx, by, bz, real. Okay. A is ax, ay, az. So now, if you do not define ax, ay, az that way, then it will actually give you an error. But now, since I've defined it, it's actually used a as symbolic variables. B equals bx, by, bz. Suppress that. And if you want to do cross, okay, I've never tried this. Let's hope it works. That's the product. Okay. So if you want to do, I don't know, when you do your homeworks, not in the previous classes, you used to do these calculations by hand, right? Numeric, you can actually use MATLAB to do it. And then you can actually, a bunch of other things you can do. You can actually write code, and then you can write C code, and you can take MATLAB code, convert to C code, and there's a command to do that. It's a very useful language, MATLAB. If you are more of the person who likes C, then, well, MATLAB is good. I use MATLAB to develop initially my code and get it to work. Once I know that